If Germany had decided to mass-produce the Ferdinand tank destroyer instead of building just 90 vehicles in 1943, they would have faced engineering challenges so severe that the entire program could have collapsed within 6 months, costing them more battlefield victories than it delivered. This isn't speculation. This is what German engineering documents and battlefield reports actually reveal about one of World War II's most misunderstood armored weapons. The Ferdinand achieved a kill-to-loss ratio of approximately 10-1 at the Battle of Kursk, destroying 320 Soviet tanks while losing only 13 Ferdinands to enemy action. Those numbers sound miraculous until you discover that 39 Ferdinands became total losses during that same operation, and the reason why tells you everything about whether mass production would have changed Germany's fate. Most documentaries celebrate the Ferdinand's 200mm frontal armor and its devastating 80mm Pak 43 gun that could penetrate any Allied tank from over 3,000 meters. But they don't tell you about the 5 Panzer IV recovery vehicles that had to be linked together just to tow one broken-down Ferdinand off the battlefield, or that Germany didn't even have enough of those recovery vehicles when Kursk began. They don't mention that this 65-ton monster consumed 833 liters of fuel per 100 kilometers, or that its petrol-electric transmission required 940 kilograms of copper per vehicle when Germany was desperately short of that strategic material. The question isn't whether the Ferdinand was powerful. The question is whether building thousands of them would have won Germany the war or accelerated their defeat. Let's establish the context that makes this scenario so fascinating. In early 1942, Ferdinand Porsche was convinced his VK-45 1P design would win the competition to become Germany's new heavy tank. So confident was he that Porsche began manufacturing approximately 100 chassis at the Nibelungenwerk factory in St. Valentin, Austria, before the competition was even decided. Each chassis featured Porsche's innovative petrol-electric drive system, 2 Maybach HL 120 TRM engines, each producing 300 horsepower, driving electric generators that powered electric motors connected to the drive sprockets. This system offered theoretical advantages including infinitely variable speed control, excellent low-speed torque for climbing obstacles, and the ability to reverse at the same speed as forward motion. But when testing occurred, the Henschel design proved superior in reliability and simplicity, and Hitler selected it for production as the Tiger I. Porsche now had 100 obsolete chassis and a massive problem. Rather than scrap them, German planners decided to convert these chassis into heavy tank destroyers, mounting Krupp's newly developed 80mm Pak 43-2 gun, the most powerful anti-tank weapon in the German arsenal. The conversion required extensive modifications, additional 100mm armor plates riveted to the front, bringing total thickness to 200mm, a massive casemate superstructure to house the gun, and relocation of the engines from the rear to the middle of the hull. The fighting compartment moved to the rear, creating a vehicle unlike anything previously fielded. By February 1943, construction began, and by May all 90 vehicles were completed and organized into 2 heavy tank destroyer battalions, the 653rd and 654th, specifically for the coming summer offensive at Kursk. Now here's the first critical fact that destroys the mass production fantasy. The Ferdinand required components from multiple specialized manufacturers operating across German-controlled territory. Eisenwerke Oberdonau from Linz modified the hulls. Siemens Schuckert of Berlin provided the electrical motors and generators. Krupp from Essen manufactured the casemates. Nibelungenwerke performed final assembly. This distributed production chain meant that any disruption to one supplier would halt the entire program. Compare this to the Sturmgeschütz III, Germany's most produced armored vehicle with over 10,000 built, which was manufactured at consolidated facilities that could achieve economies of scale. The Ferdinand's production required coordination across facilities separated by hundreds of kilometers during a period when Allied strategic bombing was systematically targeting German industrial centers. By mid-1943, when the first Ferdinand rolled off the assembly line, RAF Bomber Command had already launched devastating raids on Essen, home of Krupp's main facilities. The November 22, 1943 raid on Berlin, where Siemens Schuckert was located, killed 2,000 people and rendered 175,000 homeless, while destroying multiple industrial facilities. If Germany had attempted to scale Ferdinand production to even 500 vehicles, they would have needed to expand this vulnerable supply chain precisely when Allied bombing was intensifying. The October to December 1943 period saw Allied bombing cause production failures of 4% for Tiger tanks, 35% for the 88mm PaK 43-41 anti-tank gun, and 16.3% for Stugge assault guns. Mass Ferdinand production would have suffered similar or worse disruption rates, but the copper requirement represents an even more insurmountable barrier that most analysis completely ignores. Each Ferdinand's petrol-electric transmission consumed approximately 940 kilograms of copper for the generators, electric motors, wiring, and control systems. For comparison, an entire Tiger I tank with conventional mechanical transmission required only 93 kilograms of copper. If Germany had built 1,000 Ferdinands instead of 90, the additional copper requirement would have been 850 to 400 kilograms, 856 metric tons of a strategic material that Germany was critically short of throughout the war. Germany's copper situation was so dire that by 1943, they were stripping copper from civilian infrastructure, churches, and monuments to sustain military production. Turkey was Germany's primary external copper source, but Turkey didn't sell Germany any copper until 1942-1943, when German stockpiles were nearly exhausted, and then cut off all sales in April 1944 based on Allied pressure and battlefield developments. The Allied economic warfare campaign specifically targeted copper supplies, with Britain and America buying up neutral stockpiles to deny them to Germany. Every kilogram of copper diverted to Ferdinand production meant less copper for electrical, wiring and aircraft, radio equipment for communications, shell casings for artillery, or the 1,000 other applications where copper was irreplaceable. German war planners faced constant trade-offs between competing priorities, and dedicating nearly a ton of copper to each Ferdinand would have required cutting production elsewhere. The likely result would have been fewer fighters to contest, Allied air superiority, less artillery ammunition for defensive operations, or reduced communications equipment degrading battlefield coordination. The fuel consumption numbers tell an equally devastating story that gets worse the more Ferdinands you imagine deploying. The Ferdinand consumed 833 liters per 100 kilometers on roads and approximately 1,000 liters per 100 kilometers cross-country, giving it a maximum operational range of 130 to 150 kilometers on roads and only 90 kilometers off-road from its 950-liter fuel capacity. Germany's oil situation deteriorated catastrophically after 1943, when Allied strategic bombing targeted synthetic fuel plants, and Romania's Ploiești oil fields came under air attack. By 1944, fuel shortages were so severe that German armor often couldn't move, and many tanks and tank destroyers were abandoned in place when units ran out of fuel during retreats. A Ferdinand battalion with 45 vehicles operating at full capacity would require approximately 37,485 liters of fuel per 100 kilometers of road movement, or 165 tank trucks of 2,000-liter capacity to sustain a 500-kilometer advance. The logistics of supplying this fuel in a combat environment where Allied fighter bombers dominated the skies and attacked any concentration of vehicles was nearly impossible. Soviet and American forces regularly reported discovering abandoned German armor that was mechanically functional, but had been left behind due to fuel exhaustion. If Germany had fielded 10 Ferdinand battalions instead of 2, the fuel requirements would have been 5 times greater during a period when fuel supplies were declining, not increasing. The tactical power of the Ferdinand's gun and armor becomes irrelevant when the vehicle can't reach the battlefield, or must be scuttled after the first engagement because no fuel exists for withdrawal. Let's examine what actually happened at Kursk to understand how the Ferdinand performed under optimal conditions before considering mass production. The Battle of Kursk, launched on July 5, 1943, was Germany's last major offensive operation on the Eastern Front. 89 Ferdinands participated, the largest deployment of the type during its entire service life. The vehicles were organized into heavy tank destroyer battalions 653 and 654, attached to the 9th Army attacking the northern face of the Kursk salient. Initial German reports were enthusiastic. The Ferdinand's 80-80mm Puck-43 gun destroyed Soviet T-34 tanks and 76.2-meter anti-tank guns from behind the front lines at ranges exceeding 3 kilometers, distances where Soviet weapons couldn't effectively return fire. The 200mm frontal armor proved nearly impenetrable to Soviet anti-tank weapons, with shells bouncing harmlessly off the thick plates. Soviet intelligence identified the Ferdinand as a priority threat, and interrogations of German prisoners captured in the first week provided organizational details and tactical employment information. But within days, the tactical situation revealed the Ferdinand's critical vulnerabilities. Soviet defenses at Kursk were arranged in depth, with extensive minefields protecting each defensive line. Ferdinands advancing through these minefields suffered track and suspension damage that immobilized them, despite their armor remaining intact. The vehicle's 65-ton weight made recovery extraordinarily difficult. Standard German recovery vehicles couldn't move a disabled Ferdinand, and the specialized Bergepanzer Ferdinand recovery vehicles didn't exist yet, because no one had anticipated the need. German recovery doctrine at the time assumed that a Bergepanzer IV could tow most disabled vehicles, but recovering a Tiger I required 3 Bergepanzer IVs linked together, and a Ferdinand required 5. Most German tank units didn't have 5 recovery vehicles available to dedicate to a single Ferdinand, meaning that any Ferdinand immobilized near or beyond German lines had to be either repaired in place under fire or destroyed to prevent capture. The mechanical reliability problems that plagued the Ferdinand at Kursk would have been catastrophically amplified by mass production. German after-action reports documented that nearly all Ferdinand tank destroyers required some repair due to mine damage or mechanical issues during the first week of operations at Kursk, with 4 vehicles classified as unsalvageable total losses purely from mechanical failure, not enemy action. Repair shops faced chronic shortages of spare parts because the Ferdinand's unique petrol-electric drive system required components that weren't interchangeable with other German vehicles. A broken transmission on a Panzer IV could potentially be cannibalized from another damaged Panzer IV. But a failed electric motor on a Ferdinand could only be replaced with another Ferdinand electric motor, and production of spare parts lagged far behind the demand created by combat operations. The Germans documented 39 Ferdinands as total losses by the end of Operation Citadel in early August, but the causes reveal the real story. 20 Ferdinands were deliberately blown up by their crews to prevent capture, after mechanical failures immobilized them and recovery was impossible. Only 13 Ferdinands were confirmed destroyed by direct enemy action. This means that mechanical breakdown and the inability to recover damaged vehicles accounted for more losses than Soviet tanks and anti-tank guns combined. Now imagine multiplying this problem by a factor of 10 or 20. If Germany had deployed 500 Ferdinands instead of 89 at Kursk, they would have needed 2,500 Bergepanzer IV recovery vehicles linked in groups of 5, just to handle the inevitable mechanical casualties. But Germany's entire Bergepanzer IV production through 1945 was only 36 vehicles. The mathematics of logistics and recovery capability made mass Ferdinand deployment operationally impossible regardless of how many you could theoretically produce. What most people miss about the Ferdinand is that its technical specifications created a vehicle that was simultaneously too heavy and too specialized. The 65-ton weight exceeded the load capacity of most bridges in Europe, forcing Ferdinand units to carefully plan routes and often accept significant detours to reach operational areas. The Panther tank at 45 tons could use virtually any substantial bridge, and the Sherman at 30 tons had essentially unlimited bridge access. A Ferdinand column couldn't simply follow marked roads. Engineers had to survey bridge capacities in advance, identify suitable crossing points, and often construct reinforced bypasses. This planning overhead consumed time and resources that increased exponentially with the number of Ferdinands deployed. The specialization problem was equally constraining. The Ferdinand mounted an excellent anti-tank gun in a heavily armored casemate, making it superb for defensive operations where it could use its long-range firepower from prepared positions, but it lacked the flexibility of turreted tanks that could engage targets in any direction without repositioning the entire vehicle. The original Ferdinand lacked any machine gun for close defense, making it vulnerable to infantry attack once enemies closed to ranges where the main gun couldn't depress sufficiently to engage them. This vulnerability became so problematic that the 48 surviving Ferdinands were recalled to Dnipropetrovsk in late 1943 for modifications that added a hull-mounted MG-34 machine gun and improved the commander's cupola. The modified vehicles were renamed Elephant, and Hitler personally directed their deployment. But this modification process took months, removing the vehicles from frontline service during a critical period when German forces were conducting fighting withdrawals across Ukraine. The Soviet response to the Ferdinand demonstrates why mass production wouldn't have delivered the battlefield advantage Germany needed. Soviet tank design philosophy emphasized mass production of adequate vehicles over small numbers of superior ones, and they applied this same thinking to countering the Ferdinand. The Su-152 self-propelled gun, mounting a 150mm howitzer on a KV-1S heavy tank chassis, proved capable of destroying Ferdinands through blast effect, even when shells didn't penetrate the armor. The massive 152mm high-explosive round produced concussive force that could kill or incapacitate the crew through spalling fragments of interior armor breaking off and ricocheting through the crew compartment. Tests on abandoned Ferdinands at Poniri revealed that some had been set fire with Molotov cocktails not by Soviet infantry, but by German crews who abandoned their vehicles when they became immobilized. The Su-152 earned the nickname Zveroboy, Beast Killer, for its ability to reliably engage the heaviest German vehicles. By December 1943, Soviet industry had produced 670 to 704 Su-152s, and production transitioned to the improved ISU-152, using the IS tank chassis, with thousands eventually produced. This asymmetric Soviet response, building specialized vehicles to counter German heavy armor while continuing mass production of T-34 medium tanks, meant that every Ferdinand Germany deployed would face multiple Su-152s or ISU-152s that could destroy it through methods that negated its armor advantage. The Soviets could replace losses faster than Germany could produce Ferdinands, creating an attrition dynamic that favored the side with greater industrial capacity. Here's where the alternative history scenario collapses under its own contradictions. Suppose Germany had somehow overcome the copper shortage, the fuel crisis, the recovery vehicle deficit, the spare parts bottleneck, and the Allied bombing campaign to produce 1,000 Ferdinands by mid-1944. Where would they deploy them, and what missions would they perform? The Ferdinand's design optimized it for defensive operations from prepared positions, but by 1944, Germany was conducting fighting withdrawals on all fronts. Defensive positions only remained viable for days or weeks before Soviet or Allied advances forced German units to retreat, and every retreat created logistical nightmares for heavy vehicles like the Ferdinand that couldn't move quickly and consumed enormous quantities of fuel. The Eastern Front after Kursk featured continuous Soviet offensives that pushed German forces back hundreds of kilometers. Ferdinand units would repeatedly face the choice between abandoning immobilized vehicles or dedicating recovery assets to towing them during retreats where speed was essential. The historical record shows that German heavy tank battalions often left disabled Tigers behind during withdrawals. Because recovering them was impossible under combat conditions, the same problem would afflict Ferdinands to an even greater degree due to their superior weight. In the West after D-Day, Allied air superiority was so complete that any concentration of German armor drew immediate air attack. The Hawker Typhoon rocket attack and the P-47 Thunderbolt fighter bomber created a tactical environment where German armor could only move at night, severely limiting operational mobility. Ferdinand battalions attempting to redeploy to threatened sectors would face Allied fighter bombers during daylight movement, and the Ferdinand's thin top armor was vulnerable to rocket and bomb attack. The production trade-offs required to build more Ferdinands would have actively harmed German military effectiveness in areas that mattered more. The Jagdpanther tank destroyer, which entered production in January 1944, represented everything the Ferdinand should have been. Powerful 88mm Pak 43 gun, good armor protection with slope design, based on the proven Panther chassis, reasonable weight at 45 tons, and conventional mechanical drive system. Only 413 Jagdpanthers were produced by war's end, despite goals of 150 per month. primarily because Allied bombing disrupted production and resources were insufficient. If Germany had dedicated the steel, labor, and manufacturing capacity for 1,000 Ferdinands, they would have been forced to cut Jagdpanther production even further, trading a better tank destroyer for a worse one. The Sturmgeschütz III assault gun, Germany's most produced armored vehicle, provided excellent anti-tank capability with its long 75mm gun, while being far cheaper and easier to produce than the Ferdinand. More than 10,000 Stügge 3s were built from 1940 to 1945, and they equipped assault gun battalions and brigades throughout the German army. The Stügge 3 could destroy any Allied tank at typical combat ranges, was reliable, easy to maintain, and could be produced in massive numbers. Every Ferdinand built meant fewer Stügge 3s, and the trade-off favored the Stug overwhelmingly. Germany's critical shortage wasn't high-end tank destroyers that could engage at 3,000 meters. It was mobile, reliable anti-tank weapons in sufficient numbers to defend against the thousands of Soviet T-34s and American Shermans that were overrunning German positions through sheer numerical superiority. German tank destroyer doctrine evolved significantly during the war, and the changes reveal why the Ferdinand's design concept was becoming obsolete, even as it entered service. Early German tank destroyer doctrine emphasized offensive action. Fast, lightly armored vehicles like the Marder series would aggressively seek out and destroy enemy tanks using superior mobility and firepower. The Marder III, mounting either a captured Soviet 76.2mm gun or German 75mm Pak-40 on a Panzer 38T chassis, provided exactly this capability. Over 1,400 Marder IIIs were built, and they proved effective in defensive and counterattack roles despite their open-topped crew compartment and thin armor. But combat experience, particularly in North Africa and on the Eastern Front, forced doctrinal changes toward defensive ambush tactics. Tank destroyers were increasingly positioned in depth along defensive lines, waiting in concealed positions to engage enemy armor as it advanced. The 1944 edition of Field Manual 18-5, Tactical Employment Tank Destroyer Unit, eliminated references to offensive action and emphasized stealth, deception, and defensive fighting from prepared positions. This doctrinal shift meant that the Ferdinand's lack of mobility mattered less than it would have under earlier doctrine, but it also meant that cheaper, more numerous tank destroyers like the Hetzer could perform similar missions. The Hetzer, mounting a 75mm Pak-39 gun on a modified Panzer 38T chassis with fully enclosed armor, entered service in 1944 and proved highly effective despite weighing only 16 tons. Nearly 3,000 Hetzers were produced by war's end, and they could be manufactured far more quickly and cheaply than Ferdinands while providing adequate anti-tank capability for defensive operations. The intelligence and tactical adaptation cycle further undermined any potential advantage from mass Ferdinand deployment. By late 1943, Allied intelligence had thoroughly analyzed captured Ferdinands and disseminated vulnerability information to combat units. Weak points were identified: the thin side and rear armor, the vulnerable tracks and suspension, the lack of secondary armament on early models, and the mechanical unreliability that often immobilized vehicles without direct combat. Soviet tactical instructions specifically directed units to engage Ferdinands from the flanks using T-34s and Su-152s, to employ anti-tank guns in ambush positions where Ferdinands would present side shots, and to use infantry anti-tank weapons and mines to immobilize them for subsequent destruction. American forces developed similar tactics against German heavy armor generally. Use air support and artillery to force German tanks to button up or retreat. Employ tank destroyers with 90mm guns to engage from hull-down positions where the Ferdinand's height became a liability. And bypass strong points when possible, to let following infantry reduce them. The more Ferdinands Germany deployed, the more combat experience Allied forces would accumulate fighting them, accelerating the development of effective countermeasures. Unlike the Tiger tank, which remained rare enough that many Allied tank crews never encountered one, mass-produced Ferdinands would become familiar opponents that Allied units learned to defeat through practiced tactics. The economic calculation reveals the final nail in the mass production coffin. We don't have exact production costs for the Ferdinand, but we can estimate based on related vehicles. The Tiger I cost approximately 300,000 Reichsmarks to produce, while the Panzer IV cost about 115,000 Reichsmarks and the Stug III around 82,000 Reichsmarks. The Ferdinand's complex petrol-electric drive system, heavy armor, and specialized production process likely pushed its cost above the Tiger's, perhaps 350,000 to 400,000 Reichsmarks per vehicle. For the cost of 1,000 Ferdinands, roughly 350 to 400 million Reichsmarks, Germany could have built approximately 3,000 Stug IIIs or 4,800 Panzer IVs, which investment would have better served German military needs in 1943-1944. 3,000 additional assault guns distributed across German divisions would have provided mobile anti-tank capability that could respond to breakthroughs, support counterattacks, and defend against the armored spearheads that repeatedly shattered German defensive lines. The Stug III's reliability meant that maintenance and logistics requirements were manageable within Germany's increasingly constrained supply system. Most importantly, Stug IIIs could operate effectively in the fluid, mobile warfare that characterized the Eastern Front after Kursk and the Western Front after D-Day, whereas the Ferdinand's weight and fuel consumption limited it to defensive positions that would inevitably be abandoned during Germany's continuous retreats from 1943 onward. Here's the brutal truth that alternative history enthusiasts don't want to acknowledge. By the time the Ferdinand entered service in mid-1943, Germany had already lost the war in every dimension that mattered: industrial production, resource access, strategic position, and manpower reserves. The Soviet Union was producing over 24,000 tanks per year, while Germany struggled to produce 6,000 to 8,000. American industry added another 25,000 to 30,000 tanks annually while operating, essentially immune from Axis strategic bombing. Germany's 1943 tank production of approximately 6,000 vehicles sounds impressive until you realize they were fighting simultaneously against opponents who collectively produced 50,000 tanks that same year. No amount of technical superiority at the vehicle level could overcome this disparity in strategic production capacity. The Ferdinand exemplified German engineering excellence, creating sophisticated weapon systems that consumed disproportionate resources while delivering marginal returns compared to simpler alternatives. Germany needed quantity and they kept building quality. They needed reliability and they kept engineering complexity. They needed logistics sustainability and they kept designing vehicles that required specialized support. Mass-producing Ferdinands would have accelerated these counterproductive trends, diverting resources from weapon systems that might have extended the war while producing marginal improvements in battlefield capability that couldn't reverse Germany's deteriorating strategic position. The counterfactual scenario where mass-produced Ferdinands somehow changed Germany's fate requires assuming away all the constraints that made the historical outcome inevitable. You have to assume Germany discovers unlimited copper deposits. You have to assume synthetic fuel production increases instead of being devastated by Allied bombing. You have to assume German industry can expand distributed production chains during intensifying strategic bombardment. You have to assume Allied forces don't adapt tactics to counter the increased Ferdinand threat. You have to assume German logistics can support heavy vehicle operations during continuous retreats. Every assumption contradicts the historical evidence. The reality is that the Ferdinand succeeded in its limited deployment precisely because Germany could concentrate resources on 90 vehicles, provide intensive crew training, select optimal deployment locations, and supply sufficient fuel and ammunition for short-duration operations. Expanding production 20-fold would have diluted all these advantages, while multiplying every logistical and mechanical vulnerability. Crew quality would decline as training time compressed, maintenance would suffer as spare parts shortages worsened, tactical employment would degrade as commanders received insufficient training on the vehicle's capabilities and limitations. The kill-to-loss ratio that made the Ferdinand legendary at Kursk would plummet as larger numbers operated in less favorable conditions with reduced support. The German military's late-war desperation produced numerous wonder weapons programs that consumed resources while delivering minimal battlefield impact. The Me-262 jet fighter, V-2 rocket type Bustiewent submarine, and others. These programs shared common characteristics: innovative technology, enormous resource investment, production problems, deployment delays, and ultimate irrelevance to the war's outcome. A mass-production Ferdinand program would have joined this list. The engineering challenges that plagued the limited production run would have multiplied with scale-up. Quality control would deteriorate, manufacturing defects would increase, and the sophisticated petrol-electric drive system would fail more frequently as less skilled workers assembled it under time pressure. Germany's manufacturing quality declined significantly after 1943 as strategic bombing disrupted supply chains, forced factory relocations, and killed experienced workers. Steel quality deteriorated as alloying elements became unavailable, causing armor to become brittle and prone to cracking. Transmission and final drive components made with inferior materials failed prematurely, as evidenced by the epidemic of mechanical breakdowns that afflicted late-war Panthers. The Ferdinand's complex drivetrain would have suffered similar quality degradation, reducing the already marginal reliability to catastrophic levels. Historical data on German tank availability rates shows that by 1944, only 50 to 70% of tanks in frontline units were operationally ready at any given time due to mechanical issues and parts shortages. Mass-produced Ferdinands would likely have achieved even worse availability, perhaps 30 to 50%, meaning that of every 100 Ferdinands built, only 30 to 50 would be combat-ready when needed. The final, most important consideration that destroys the mass production scenario is opportunity cost. Every hour of factory labor, every ton of steel, every kilogram of copper, every liter of fuel, every railroad car used to transport Ferdinand components was unavailable for alternative uses that might have better served German military needs. Germany's 1943-1944 situation required maximizing defensive effectiveness per unit of resource invested. This meant prioritizing anti-tank guns over tank destroyers, fixed fortifications over mobile armor, and fighter aircraft over ground vehicles. A German 75mm Pak-40 anti-tank gun could destroy any Allied tank at typical combat ranges, weighed only 125 kilograms, required no fuel, could be towed by truck or even moved by crew in emergency, and cost a fraction of any armored vehicle. Germany produced over 20,000 Pak-40 guns, and they equipped every infantry division's anti-tank battalion. For the resources required to build 1,000 Ferdinands, Germany could have produced perhaps 10,000 additional Pak-40 guns, transforming every German defensive position into an anti-tank fortress. Static defense with artillery and anti-tank guns supported by limited mobile reserves was Germany's optimal strategy, given their resource constraints and deteriorating strategic position. Mobile, fuel-hungry, mechanically complex vehicles like the Ferdinand represented exactly the wrong allocation of scarce resources. So what actually would have happened if Germany had attempted to mass-produce Ferdinands? The program would have collapsed under its own weight within months. Copper shortages would have forced production cuts or redesigned to eliminate the electric drive, creating essentially a different vehicle. Fuel shortages would have left completed Ferdinands sitting in factory yards awaiting transport to training areas where fuel wasn't available for crew instruction. Allied bombing would have destroyed critical component suppliers, halting production lines and creating a growing inventory of incomplete vehicles. The few units that received Ferdinands would have experienced catastrophic mechanical failure rates, abandoned numerous vehicles during retreats, and struggled to perform the offensive operations that German commanders increasingly desperately needed. The resources diverted from other programs, assault guns, conventional tank destroyers, anti-tank guns, artillery, would have created capability gaps elsewhere that weakened German defenses more than the Ferdinand strengthened them. By late 1944, German commanders would have been pleading with High Command to terminate Ferdinand production and redirect resources to more practical weapons. The program would be remembered as another example of German engineering hubris, producing impressive prototypes that failed at scale, like the Maus super heavy tank or the multiple failed attempts to develop operational jet bombers. History vindicated the actual decision: produce 90 Ferdinands for specialized deployment, then move on to better designs like the Jagdpanther that achieved similar firepower with superior mobility and reliability. The Battle of Kursk, where the Ferdinand achieved its legendary kill ratios, ultimately ended in German defeat despite the Ferdinand's tactical successes. The Soviets absorbed the initial German assault, stabilized their defenses, and launched massive counteroffensives that pushed German forces back to their starting lines and beyond. Strategic victory went to the side with superior numbers, better logistics, and the industrial capacity to replace losses. Germany never again attempted a major offensive operation on the Eastern Front after Kursk. The initiative permanently shifted to the Soviets, who conducted continuous offensives that ground down German forces through relentless attrition. The Ferdinand's impressive performance destroying individual Soviet tanks mattered less than the strategic reality that the Soviets could replace their losses while Germany couldn't. This fundamental asymmetry, Allied production vastly exceeding German capacity, determined the war's outcome more decisively than any technical comparison between individual weapon systems. Mass-producing Ferdinands would have accelerated resource depletion without changing the strategic balance, hastening the same inevitable defeat while making it more costly and wasted production capacity. The historical outcome where Germany built 90 Ferdinands, deployed them cautiously, achieved impressive local results, and then moved on to other designs represents the optimal path given their constraints. Any alternative involving mass production leads to worse outcomes across every meaningful metric: resource efficiency, battlefield effectiveness, strategic impact, and ultimate contribution to victory or defeat. The lesson from the Ferdinand isn't that Germany should have built more, it's that even technically superior weapons can't overcome strategic disadvantages rooted in industrial capacity, resource access, and manpower. The Allied victory in World War II resulted from outproducing Germany in every category of war material, while simultaneously strangling their access to strategic resources through blockade and strategic bombing. German attempts to compensate through technical excellence produced weapons like the Ferdinand that impressed on paper and in limited engagements, but couldn't scale to change strategic outcomes. If anything, the Ferdinand's design philosophy, maximum firepower and armor regardless of weight, complexity, or cost, represented the exact wrong approach for Germany's 1943-1945 situation. They needed the armored equivalent of the AK-47, simple, reliable, effective enough, and mass-producible with limited resources. Instead, they built the armored equivalent of a precision Swiss watch. And when you're fighting opponents who can afford to smash your expensive watches with endless hammers, the result is inevitable regardless of how precisely your watch keeps time before it's destroyed. That's the real story of the Ferdinand, and that's why mass production would have been Germany's worst possible strategic choice.